Right. We are in a discussion of AWS Solution Architect. I'm just going to start from um, whatever we had stopped rather than uh, wasting time. So this is a continuous discussion. Yeah. Now we were previous video we've been discussing with the VPC endpoints in AWS. So now we're going to talk the VPC endpoint further, and you got a picture here in the diagram. So you can see AWS Cloud and then VPC, and then you got a private subnet, and then you got a EC2 instance. Then EC2 instance to connect into S3 bucket or DynamoDB table. As an example, we're creating here a VPC endpoint. That's a S3 endpoint to connect into this one, or DynamoDB endpoint to connect into a DynamoDB table. So private AWS service access via VPC endpoint, so no internet required. So it's connecting in two services inside the AWS cloud. So what are VPC endpoints? As we discussed, VPC endpoints enable private connection between your VPC and supported AWS services without requiring an internet gateway, net gateway, or VPN or direct connect, right? So this enable improve the security of these resources, reduce data transfer cost because you got internet through data transfer through net gateway through internet and all other stuff will occur charges, and then decrease network latency because it's traffic going inside the AWS network, so doesn't have bottlenecks or anything like that, right? As we discussed previously, we mainly discuss two type of endpoints: the gateway endpoints, that is for S3 and DynamoDB, that's free of charge, the services, and then interface endpoint (ENI), Elastic Network Interface endpoint. That's for most of the other services except S3 and DynamoDB. Then got a one called Gateway Load Balancer endpoint. That's normally for a third-party appliance when we use the services load balancer endpoints, right? Uh, Here we're going to have a latency comparison, direct access versus VPC endpoints, right? See that if you go here, right? If I go here, right? So this is a latency versus AWS service. So this is you have if you have a direct access, and that's a blue color. The red sort of color is a VPC endpoint. So this is the sort of advantage you having. See that latency. This one is a S3 direct access is a 45 millisecond latency. This one is S3 32 millisecond when you're using a endpoint VPC endpoint. So this one is a DynamoDB direct access. You got 38. This one is a 25 latency, right? If this one got a sort of 65, and then if you got 42 in a lambda, right? So you can see, you could see the different between these two, right? All right. So, all right. So configuration steps. How do you configure an endpoint, right? This is the steps involving. We're not going to do it in this video, but we'll explain how do you. So identify services requiring private access. So you identify which service is needed for private access, and then choose appropriate endpoint type. So is it going to be a gateway endpoint, or is it going to be a interface endpoint ENI, and then configure security group policies. So give you access to security group policies, what ports and the range of IP addresses you need to access, and then test connectivity from the instance, right? And then just need to monitor with the VPC Pro logs how it's going to be working with this service. What are the implications and what are the problems coming in? You have to monitor with VPC logs, right? All right, so we're going to talk about advanced VPC endpoints and private links, right? Uh, got a private links is the same way like we're getting connected through on premises through a private connection, right? And let's have a look at type of VPC endpoints. Three VPC endpoints here listed: S3 and DynamoDB, and interface endpoint here that's powered by normally a AWS private link service, right? And then gateway load balancers for third-party security appliances, mostly firewalls and all other stuff, right? And private link benefits keep traffic within the AWS network, right? No public IP exposure. There's no exposure into public IP. So service provider, consumer separation, right? And scalable architecture, right? Uh, they got a sort of a diagram here, right? So your VPC, right? That inside your VPC, and you got a gateway endpoint used for Amazon is three buckets and DynamoDB, right? And then interface endpoints use AWS services or partner services or your services, right? And then this is for gateway load balancer endpoints for like a security device and third party devices, right? Okay, so this one uh, just a graph that's in this side you can see services versus this side is you can see services latency. It's latency public internet versus VPC endpoints, right? See that if you access something in a VPC endpoint, so you got a very short latency here, right? Like S3 bucket, if you see that if you use a private endpoint, this is 80% of reduction here, right? This one, right? 70 versus here 350, right? And messenger service, right? That's the same. All the services you can see when you're using them, how much latency delay is there through private public internet and use access using a VPC endpoint, right? Correct. Let's going to talk about how we're going to configuring a VPC endpoint for optimal security and performance, right? Here are the benefits configuring endpoints in optimal security and performance, right? So let's see what are the security benefits. So traffic stays within AWS network, never traverse internet. Uh, so this traffic stays inside the AWS, so it's a secure. It doesn't go through internet. So that's a good security feature. Apply IAM policies for granular access control. So you can use IAM policies, identity and access management policies for granular level control for each service, right? And then use security group for restrict traffic. So you can use mostly instant level security group for ENI, right? and then that will restrict traffic even within the private subnet. Implement private DNS for interface endpoints. So these interface endpoints will be identified using a private DNS. Sort of, I remember we did one session for Azure private DNS. Sort of, it's internally identified, right? And then the other benefit is performance optimization, right? For the base performance, place endpoints in multiple level will be shown for real reliability. So reliability endpoints in the multiple availability zones. Choose optimal endpoint type for each service. Use what is the best endpoint type for the service, and monitor endpoint using performance metrics. So this ENI endpoint cost you money. So make sure you use metrics to examine how much data is flowing or not occurring extra cost for you, right? Use private link for low latency connection. So private link connection. So use that one for lower latency connection. So the best practice, audit endpoint policies regularly, right? Audit the policies, make sure you given the least privileges access, and use CloudWatch for monitoring. Consider cost versus performance trade-off, right? And test failover scenarios. Uh, Wherever possible, if you put in a different multiple availability zones, check the scenarios of failover, at least telling in the quarterly to make sure the works if something happen, right? Got high availability. All right, scenarios for using gateways versus interface VPC endpoints. We discussed this one earlier as well, but just going to go quick recap. VPC endpoints overview. So VPC endpoints enable private connection between your VPC and supported AWS service without requiring internet gateway. So improve security posture, reduce data transfer cost, lower network latency. So use gateway endpoint for S3 and DynamoDB. So interface endpoint for everything else, right? Mostly, right? So use interface endpoints and gateway endpoint, right? Uh, all right. So see that this one shows right. Uh, this is workload type, right? And latency. It gives you you don't need to remember, but I just give you one idea. The how much is going to be getting a latency if you're using a inter right gateway latency and interface latency, right? So within a web server, this much gateway latency is a web server interface latency, and then a gateway through output in this graph. Um, I don't think it's really needed this sort of a comparison, but uh, just like different services like API calls, batch processing, file transfer, how much latency in these ones, right? So interface endpoint scenarios, right? Private API access, secure access to AWS API endpoints or application programming interfaces, right? The service coverage for services not supported by gateway endpoint, right? Cross-region access when accessing services in a different region, right? So interface endpoint scenarios you can use. Gateway endpoint scenarios S3 access, data processing application needing cost-effective access, right? DynamoDB operation, high throughput database traffic requiring no bandwidth charges, right? regional services operating within the same AWS region, so you can use the gateway endpoint scenarios, right? All right. Now we're going to discuss VPC peering connection. This is similar to VNet peering, right? A networking connection between two VPCs that enable direct private communication using private IP addresses, right? That works across different accounts and regions. So remember, it's possible with the different accounts and regions, right? You might be asking in the questions, right? No single point of failure or bandwidth or bottleneck. Use backbone network, right? Traffic remain on AWS network. Never traverse public internet. Doesn't go through a public internet. The same. So create peering connection request. Not like in where Azure, we just have to accept the connection request in here. You create, then accept connection and update. Then you have to update route tables in both VPC, right? You need to make sure you use this VPC and that second VPC, and then you modify security group to allow the traffic, whatever you need to access the services, right? Um, as like in a limitation, no transitive peering. So remember, I explained in a previous video, you got three VPCs, A, B, C. So A connected to B connected to C doesn't mean A connected to C. So if you want A to C, you need to separate uh, peering connection request and then accept connection request. And then you do route tables and modify security groups in both services and both VPCs. So maximum 125 peering connection per VPC. The other thing is no overlapping CIDR blocks, same as in Azure. So make sure if you have different VPCs, make sure you're using not overlapping CIDRs, like something using 10.0.1.0. The second one using 172. If you have a third one, you can use 192.168 or uh, whatever, not overlapping ones, right? All right, we're going to talk about VPC integration with the on-premises network and type of connections available. Remember, we have done few videos with the AWS, like VPN connection, virtual network gateways, sort of things. So hybrid connection. So here we're going to talk about on-premise network connection and then sort of options available, right? So here you could see in the diagram, you can see left side you get a AWS cloud with a one VPC with a public private networks, right? And then right hand side you got a symbol for on-premises network. So availability connection options are you've got a AWS site-to-site VPN, encrypted IPsec connection over the internet, right? A VPN connection, encrypted tunnel, and then you got a AWS Direct Connect. So they're giving you a dedicated private network connection from your premises to AWS cloud, and then the other one is extending the network is a transit gateway, hub for connecting VPCs on premises network. So I just have to do Azure virtual WAN. That's where we stop in Azure series. But Here, the same thing like a transit gateway connecting a few more hubs, right? So, key benefits in these ones, right? Extended network, so access cloud resources from your premises on premises, like hybrid. So, you got a hybrid architecture, gradual migration path. These guys are normally gradual migration path. So your services put it in AWS. That's what they're saying. But in like in um, uh, Azure, more towards hybrid connections available. Like they got Active Directory in on premises, and then you got connector, and then you can control most of things. So they are sort of AWS sort of like a cloud mostly. Uh, it's my personal one, but don't take any misunderstanding. Consistent security, end-to-end security controls, right? So AWS connectivity options, right? So let's have a look what this graph says, right? So it's one side is a rating, higher is better, and the other side is services, right? So they're just comparing. You don't need to remember, but just to get a common idea. Uh, whatever the telling here, connectivity options comparison. So direct connection option, right? So what do you have? A direct connect. So first, blue color is bandwidth capacity. The red color is latency and cost efficiency, right? So the telling direct connect, right? What do you have in direct connect? Let me enable Hoover. So direct connect, right? So this one, like rating, higher is better, right? Direct connect is a better option, right? Side to side VPN uh, is less. Transit gateway is in the middle, right? Sort of things, cost efficiency, right? This is uh, direct connect is most cost effective. Uh, Side to side VPN is expensive option here. This transit gateway is in between them, right? Just sort of things. Bandwidth capacity is here is high. More or so higher is better. So higher is better. That's what this is rating. Higher is better. So direct connect seems uh, side-to-side VPN in the it's harder to tell. I mean, it's all depend on whatever your services, whatever how your organization looks like. Correct. Let's have a look at how we're going to optimize the VPC networking costing, right? And so cost optimization and strategies, right? Uh, Higher cost, optimize cost, use VPC endpoint to reduce net gateway cost. All right, so what it says, cost optimization strategies. So right side blocks to prevent wastage. So use right size and keep it for mm, expanding. Use VPC endpoints to avoid public data transfer fees. So keep within inside the AWS network to make sure you don't have data transfer fees. You're paying data going through internet, right? Um, Implement net gateways sharing across multiple subnets. So share net gateway across multiple subnet, one net gateway, but if it's a, high availability, so you have to put a, per availability zone net gateway for high availability, but to reduce the cost, multiple subnets, you can use private subnet as a one uh, net gateway. But if something happened to that net gateway, uh, you'll be in trouble. So it's a uh, failure, right? It's all depend on money and how critical is the service. Consider transit gateway for complex multi VPC setup, right? So here, just cost in US dollars, right? Connected per hour per GB process, and hourly cost just given an idea how much cost is occurring, right? So dollars, right? See that per GB cost net gateway, and then a VPC endpoint, and then a transit gateway, right? And then data transfer cost, right? Uh, Let me have a look. I can see that, right? That gateway for per GB process 0.045, right? 0.045. This one is 0.01, and this one is 0.05, 0.09. All right, so monitoring and governance, right? So to manage this cost, use Cost Explorer and track networking expenses. Set up cloud virtual arms for cost threshold. So set up a cloud virtual arm is something that with the threshold, you get a message and then you can have a look. Implement resource tagging for cost allocation. So you tag the resource and then you can track how much cost is occurring. Review unused resources regularly. If you have any resources you've been using without using of that service, just it probably be only expense. So you make sure then you control that resource and get rid of that if you don't need, right? And let's have a quick catch up with some of these points. Designing a secure and cost-effective AWS network. This for common understanding. So security first approach implement depends in depth with multiple layers. So use private subnet for sensitive workloads. Apply least privilege access control for basically you put a multi-layer sort of security. So that means like in here, if I consider this diagram as a security wide, so this is VPC, right? VPC, and then network ACLs in a subnet level, and then a security group in a instance level, and then like you accessing anything in a private subnet, you put a bastion in public subnet, and then logging into that one, and then access from here, right? And then say it's use private subnet for sensitive workload like application and database uh, workloads placed in private subnet, and then apply least privilege access control. So under IAM, use whatever only necessary to the users to access these resources, right? And then cost optimization and strategies, right? Use net gateway sharing across subnets. So private subnet use of one net gateway, but you need to again keep in mind net gateway is in one of the public subnet. If the public subnet is something happened to that one, so there's no any high availability for net gateway. So keep in mind that one. So all depend on question what you asking. So you have to cost less cost solution, use a net gateway with sharing subnet. So if you need a high availability solution, use the net gateway per availability zone, right? Implement VPC endpoint for AWS services. So because of traffic not costing inside the less costing like uh, we endpoints use some endpoints because it give you low latency and a cheaper service. I can't say traffic is free because ENI endpoint always it costing. Choose correct subnet sizing for future growth. So don't waste CIDR blocks. So use wisely how much growth in there in these subnets. So make sure you don't waste them. If you want more subnet, use wisely these CIDR blocks, right? Uh, go. All right. I think it's already 30 minutes now. I'm going to stop this video and we'll continue from uh, next video. Until then, thank you very much.